All right, hi everyone. So today we're going to be talking about data types in Java. All right, so in Java, a data type denotes a set of related runtime values. So runtime being the difference or different than compile time. So it's what happens when your program is executing. So we have primitive types, and these you've seen before. They're things like integers. So you can have 32-bit integers, you can have 64-bit integers that we call long. We can have floating point numbers. So we can have 64-bit floating point numbers, so double precision floating point numbers. And we can have character types. We can also have single precision floating point numbers. You also have character types, which are single characters. They're like strings, but simpler. And then we have Boolean types, which are, well, basically true and false values, okay? We can also have reference types, and these are more complicated. They're complex types with attributes and methods. You can have string. So remember, we had car over here, okay, with a lowercase c. We have string with a capital S. It's a reference type. It's basically characters, but like more. We have examples that we've been showing in class, like the person, okay, or the point. And these are examples that we've been having in class, okay? So this string, that's a really common one. Person and point, these are really class-specific, so course-specific ones, the ones we're using in class. And then we have scanner. So string and scanner, okay, are very common reference types that we use all the time, okay, in Java, no matter what class or what course you're taking or what project you're working on. Okay, so a variable that is declared with a type but is uninitialized is implicitly assigned to its default value. So basically, if when you create a variable and you don't say that it's equal to 1 or the letter A or something like that, then there'll be some default value that that'll be created with. Okay, so for instance, an integer, okay, a 32-bit integer, if we just do this, we don't say int I is equal to 100 like that. Okay, that's not what we're doing. We just do this. Then it will be implicitly assigned the value of 0, okay, because we didn't actually give it a value. If we have a double precision floating point number, it will be assigned 0.0, okay, instead of whatever other value we would have given it. Booleans, if you don't say what value the Boolean is when it's created, it will be given a value of false by default. Now reference types, we were talking about those earlier, right? So for instance, reference types like a string, remember it's got a capital S right there. So capital S string will be, if you don't say what its value is, it will be started up as null. If we have these imaginary or these sort of example classes that we've been having before, we create a person called Jim, it will have a default value of null. Same with other classes that we create objects from, like point, and that will be assigned null if we don't say what it's supposed to be. And then scanner, you know when we're scanning input from the user, all right, say we're creating an object called input of type scanner, but we don't say what it's equal to, like we don't actually scan something in, then it will be assigned implicitly a value of null. Okay, now, even though we are setting these up without initializing their values, we can still use them. So you, if you end up doing this, you have to make sure, okay, that the default value, like null or false or 0, is actually what you want. So generally, you want to set it up properly with a value that is explicit, okay, just so you're certain how it's starting up, okay. Now that said, calling a method that is uninitialized, okay, from a reference variable, this will crash your program, okay. So you don't want to do it typically, okay. You can do it with the primitive values, okay, but you don't want to do it with the reference values. So not with these, you could do it with that. All right. So an attribute may store the reference to some object. So for instance, you can have an attribute right here, spouse, and it is, because we're using these more complex, okay, these reference variables, okay, you can have that inside of a class. Methods may take as parameters references to other objects. So for instance, you can have an object other, okay, that's being passed in. See, this is a method right here. Okay, so you can use that. You can pass it in as an input parameter. Return values from methods may be references to other objects. Here's an example right here. So here's a class that we can create objects of type point from. All right, and you can see right here that, let me see. So we're talking about return values from methods may be references to other objects. So this right here is a method inside of my class, moved up by right here. All right, and then you can see that inside, so there's the opening curly brace, there's the closing curly brace right there. We have NP right here that's being defined of type point. Okay, so point being one of these reference types. Okay, so it's basically we're creating an object called NP, and we are going to return at the end. Once we've done something with NP, we can return NP. Okay, so we can return that. An attribute may be of type, well, array. Okay, we can have reference types that are of sort of set up as arrays, storing references, plural, to point objects. So basically inside of this array, we can set up multiple objects. So here's a class called PointCollector, and we can see that we've got a reference type right here. Okay, so we're going to create a bunch of, well, we're going to create an object called points, and it's going to be an array of this type, which means we're actually going to have a whole lot of different points inside of it. And we're going to have an integer called number of points right there. So then we're going to run a, let's see, this right here is the constructor, okay, for PointCollector. And we're saying that on initialization, we're going to set up 100 members of the array, okay, called points. That's what we're going to do. And then we're going to have a method inside of here called addPoint. There's addPoint right there. It's going to take input x and y as points for defining different points inside of this object, okay? And we're going to have an array with the number of points defined right there, okay, or set up right there, and because it's coming in from one of the attributes, all right? And let's see, what we've got right here is we have got a setup where we're basically setting up a new point object, and we're incrementing the number of points every time we do it. All right, next up, and we're setting it up inside an array called points, okay, at the location NOP, okay. Now from there we have another method, and that method right here is get the points in quadrant I, or quadrant 1. So basically, if you've got a 4-quadrant system like this, the numbers, so that's the y-axis and that's the x-axis right here. This is where x and y are positive. Here's where y is positive, x is negative. Negative, negative, so y and x are negative in this quadrant. And in this quadrant right here, let me see, this will mean that, oh, sorry, I got that wrong. Not that. This will be negative x's plus y's, and then over here this is going to be plus x's and negative y's. We're interested in quadrant 1, this one right here, where both are positive. So we want to get the number of points that are located in quadrant 1 or quadrant I. We're going to say that we have an array called PS of type point, and it has the number of points right here that is the attribute of this class right here. Okay, we're going to start a count at 0. We're going to have a for loop. The for loop begins there, and it will end, I believe, there. And then we're going to basically do we're going to run through this for loop, going through all of our points, and we're going to say that if the x value of point P and the y value of point P are both greater than 0, then we want to increment our count. Okay, we want to identify it, okay, and we want to store that inside an acknowledgement of that inside of something called PS. All right, and let's see, where was PS defined? PS was defined up here. That's your array. Okay. Now from there we need to gather. We're going to gather up those points once again in an array called Q1 points of type point with the count value right here being defining effectively the number of points that we've got in Q1 points. And then from there, we transfer all the values using a for loop. Okay, we transfer them in like this right here. Okay, so we populate Q1 points I like that. And then we return Q1 points. So for this is for that method right here. Okay, so get points in quadrant 1 or quadrant I. Again, it's to know which points are in here. We're going to return the Q1 points that are located in here. Okay, that's what that does. Now there is a link right here to more reading if you want to read up on this. All right, next up, we're going to take a look at a class called PointCollector Tester. Okay, and so this is going to be basically our main file, and we're going to have our main method inside of it. Okay, and then what we do is we run PointCollector. Sorry, we're going to create an object called PC right here of type PointCollector. And inside of it, we're going to, when we initialize it, it has no points inside of it. So if we print out the number of points that are associated with PC, that object that we just created of type PointCollector, then there's going to be 0 points inside of it. Now, if we add a point, so basically we say to point 3 and 4. So x is equal to 3 and y is equal to 4. So something like that. Then we have 1 point defined. Okay, so that's it right there. So we can say that we have a number of points of 1 if we print that out. Then we add another one. So we got a point here, 3 and 4, and then it'll be negative 3x and then positive 4. So something like that. And we now have 2 points. We have 2 points inside of the PC object. Okay. Next up, we added another point, negative 3 and negative 4. So we had, let me see, that was 3 and 4 there, then negative 3 and 4 there, and then it's negative 3 and negative 4. That'd be there. And number of points should be 3. And it is, it's 3. We're going to add in 1 more point. So we're now filling up all the quadrants right here. So it was 3 and 4, negative 3 and 4, negative 3, negative 4. Oops, that shouldn't have been there. It should have been there. And then negative 3, no, it's 3 and negative 4. So right there. Okay, so that's quadrant 1, quadrant 2, 3, and 4. And so we should now have 4 points when we call pc.nop like that. Then what we do is we ask for the number of points in quadrant 1. Okay, remember, we had 1 point there, 1 point there, 1 point there, and 1 point there. How many points in there? There should be 1. So we're going to ask for the length of PS. PS is right there. PS is defined based on the output of get points in quadrant 1. Okay, because we're returning an object of type points. Okay, it'll be returned, and it will be returned into PS right here. We're going to ask for the length of PS, which basically tells us how many points there are in PS. That should be 1. And then we can ask for the X value and the Y value, and it should be 3 and 4. Yes, it'll be 3 and 4. So you can try this out yourself. Okay. Now, there's another way of doing this, a little bit more of an advanced way of doing it, using Arraylist. And so Arraylist is basically a better type of array. Okay, so Arraylist is a better type, a better form of array. Okay, so here's an example of it. So we got PointCollector, so we're going to make a new PointCollector right here. And so we're going to create an array list of type points. Notice that we've got the greater and less than symbols that are used to define the type for the array list. And we're going to have an object called points set up that way. All right. And then what we're going to do is, and so this is an attribute inside of the class called PointCollector. Then we set up a constructor. Okay. And that constructor will basically set up a new array list like this. All right, and it will assign it to points like that, which is the attribute right there. Then from there we have a method. The method's called addPoint, and we're bringing in an object of type P into it. And then what we're going to do is when we bring in that object of type P, we're going to add 2 points, okay, the attribute inside this class. We're going to add to it the object P. And that's it for that particular constructor, right? Sorry, for that particular method right there. Sorry, for that method. But we can have another method, okay, where that method is a different type of add point, where we add in a point by defining explicitly not the object of type P, but the individual points X and Y for an object. And then in that process, we're going to add to the attribute points. Okay, so we're going to add to it, but at the same time, what we're going to do is we're going to add to it a newly created object. Okay, like this. We're going to use the constructor right there. Next up, then what we want to do is we want to call the method getPoints in quadrant 1 or quadrant I right here. Okay, and so sorry, this is going to be a method. Okay, this is another method right here. And so it's going to have a return value of an array list like that. And so what we have right here is we have a new array list that's created called Q1 points of type. It's an array list that contains objects of type point. Then we have a for loop inside of there. Okay, and we're going to iterate from 0 all the way up to the size of points like that, incrementing I++ each time. And we're going to call the get method inside of points every time we do that. Okay, and then we check to see what quadrant the point is. Is X positive? Is the X value positive? And is the Y value positive? And if so, then we add to Q1 points that object. And then finally, once we're all done with that, we have only the objects that are stored inside of Q1, so quadrant 1, and we're going to return it. We're going to return it like this. Okay. Now, we have talked about this before. This is in a previous video. This for loop right here, that goes like that. It ends right there. Can be replaced by a for each loop. Okay, this is a for each loop. And you can see the structure of it is slightly different than a regular sort of iterative for loop. Okay, where we have the semicolons there separating out the 3 components. We have a colon right here, and we're going to iterate through all of the objects or all of the components of points. And every time we do it, we're going to update a variable called P. That variable P of type point, every time there's a new one, it will be added to Q1 points. That's a for each loop. Okay, that's used. Very common in Java. All right, so then we're going to look at PointCollector tester. Okay, so this is the main method inside of PointCollector tester right there. And so what we have right here is we have the, let's see, so we've got, inside here we've got a call to PointCollector. So we're going to create a new object called PC of type PointCollector. And then we print out initially what the size of that is going to be. Okay, and it should be 0 because it's just initialized. We're going to add a point. Then we're going to ask for the size. It should be 1. So we have 1 point defined in there because it's in quadrant 1, right? 3 and 4 right there. -3 and -4 is now defined. So we got 1 there. Now we're going to have negative, yeah, like that. We should now have 2 points inside. Then we add -3, -4. So we've now got 1 point there, 1 point there, 1 point there. There's now 3 points inside of the object. Then we're going to add another point to PC. This time it's going to be 3 and -4. So we had 1 point there, 1 point there, 1 point there. And now we're going to add this point right here. And there are now 4 points that have been defined inside of PC. We have to figure out which of those points, how many of those points are in quadrant 1. Okay, so we're going to take PC. We're going to run get points in quadrant I or quadrant 1. And we're going to return that value to PS. Okay, and PS is going to be an array list of type point. And then we're going to ask for the length of that array called PS, and it should be 1. Okay, it will be. And then we can ask for the position, sorry, the X and Y values at the 0th member of PS, and that should give you the value of 3 and 4. And there we have it. So a quick overview of data types, including a look at array lists.